What's new in Java 23 and why should you care about it? Find out from the best leaders and experts who are closely involved in creating these new Java features and the ones who will help you to use them. In today's episode of JEP Explained, we'll cover JEP 474, which is about the ZGC. What about it? It mentions switching the default mode of the ZGC, which is the Z garbage collector, to the generational mode and deprecates its non generational mode. What is a generational mode and what benefits does it offer? And what are the issues with deprecating its non generational mode? Let's find out. Get ready to discover what you have been missing all these years. Hi everyone, I'm your host Mala Gupta from JetBrains, and to talk about JEP 474, we have with us today Monica Beckwith, Java Performance Engineer, IC Lead of the JVM Group at Microsoft, also a speaker and a Java champion. Hey Monica, a pleasure to have you with us today.
Well, the pleasure is all mine. Thank you for having me. I really appreciate the opportunity. Thank you.
Definitely, the pleasure is all ours and everyone who would be listening to this interview. And Paul Bakker, software engineer with Netflix, also a Java champion, author, and speaker. Hey, Paul, it's a pleasure to have you present with us today.
Hey, good morning. Thanks for inviting me.
So, with two great experts in this interview, so I am looking forward to learning from both of you. So, Monica, I want to start with you. This step mentions two main points for the ZGC changing the default mode to the generational mode and deprecating the non generational mode. But before we dive into the details of these 2 points, because this interview would also be watched by a lot of newbies, and also because you're an expert on garbage collectors, could you help us understand briefly about these 2 points? What is a ZGC and what do we mean by its generational and non generational?
So ZGC is our latest addition to OpenJDK garbage collectors, and it kind of builds on the latency or low latency needs of the Java ecosystem. So it kind of it takes the regionalized and incremental aspects that were introduced in G1, and it kind of brings it and adds to the low latency. So basically, the pause times are not uh, dependent on your live data set. So it kind of fills a niche that we didn't have. Um, uh, with what CMS could not achieve before. So that's in a nutshell what ZGC can bring to the table. Now, generational and non-generational. Um, so when we introduce a garbage collector, we introduce it for what it is capable of. So that is a simple non-generational aspect of it. So the first introduction is non-generational, and then what we have seen in OpenJDK that most of the applications, most of the Java applications that run on top of the JVM, have this follow this non-generational. Follow this generational hypothesis, which means that most objects will die young. So when that happens, you don't want to invoke your, if you have a large heap, especially, you don't, and with lot of object churn, you don't want to invoke the garbage collector every time for a large heap because you got to go through the marking and everything. So we divide OpenJDK garbage collectors, they will divide the heap into young and old generation, and you take advantage that there are short-lived objects that will age or die in the young generation and only promote the long-lived objects. So that's something that is always there in OpenJDK, and now ZGC is entering that realm.
It sounds interesting, and I'm sure we will talk more about the implications of all these features that you talked about. So, Paul, before we talk more about ZGC, would you like to comment on who's the target audience for this feature? Because a lot of times what happens is when a new Java version comes out, when we see a new JEP, a lot of developers like to kind of discount some of the topics saying, this is for the Java performance engineers. So, are we talking about like the target audience? Is it someone like Monica, who's a Java performance engineer, or someone like you, a software senior developer, or is it for all the Java developers?
I really think it's for all Java developers because if you really go into the specifics of this JEP, it is really about changing the default, right? From the default used to be non-generational and now it's generational. So the JEP itself is maybe very small, but I think the really important aspect is that in Java 21, the generational ZGC was introduced, and that is really the big feature that we are looking at, and that's now the default. So I think it's interesting for everyone because what we have found at Netflix is that generational ZGC is a really good default garbage collector for most of our workloads. Well, previously, without the generational mode of ZGC, it was only a good garbage collector for very, very specific workloads. And G1 was better for like the general case. So now that we have learned that it's actually a really good general purpose garbage collector, but only if you put on the generational mode, I think it makes a lot of sense that we flip the default and kind of there's no reason to use the non-generational version anymore. And that's also why it's deprecated. So yeah, I think the JEP itself maybe is very small, but this bigger feature of generational ZGC is interesting for almost every Java developer, I think.
That makes sense. Also, if developers know about the details of the garbage collectors, they would be, I think, more efficient with writing their own applications because they understand how particular garbage collectors work. So that makes a lot of sense. So, Monica, I want to talk about different garbage collectors, which we already have. So, what do you think how the different garbage collectors are suited for different kind of applications? Like, for example, what gains are we looking at for different GCs like Serial, Parallel, Shenandoah, G1GC, or ZGC?
There are two aspects that I can talk about with respect to garbage collection in OpenJDK. The first aspect is from what we deliver as JVM developers. What are we giving to the community? So we start with Serial GC, which is kind of like a very simplistic GC. It deals with single-threaded nature. So it has very low footprint, and it is meant for applications that have low footprint. So smaller heaps, single-threaded, and very steady CPU utilization, kind of. So it doesn't like bumpy allocations or whatever. So it's kind of more steady, and it can keep pace when that's the domain. Then we offer the throughput collector, which was the default for up until Java 9. And that employs multiple threads for young and old generation. And it kind of spans larger heap, but it's more suited for batch processing. So it stops the world, as in the garbage collection pause, which means that the mutated threads, the application threads are paused, and the garbage collection doesn't work. So, but it's very sensitive to the live data set, and it's very sensitive to object churn. So then G1 was introduced, and G1, if you look at the paper, it was single generation. So that's exactly how G1 started as well. And then it went a young and old generation. And what we do there is we introduce the concept of incremental pauses and regionalized heaps, so we can have more granularity with respect to the way we stop the world, right? So you see the trend where we're going single threaded, multiple threads, stop the world. Now we are having more granular approach, and then we also have concurrent marking. So we're entering into the realm of balancing throughput with latency. And then we go into Shenandoah and ZGC, which are both targeting lower latency. So They're trying to keep the stop the world pauses to a minimum. In ZGC's case that we're talking about that. What it does, it tries to strive for sub-millisecond pauses, which means that you just have a pause for initial marking, which means the root set. But also with your live data set, the pause doesn't grow, so it kind of still does this kind of incremental concept, and it kind of weaves it with concurrent marking and concurrent collections. So if you look at a stop the world pause, one of the major things with stop the world pauses is its copying phase. So when you have live objects, you have to move the live objects and that's how OpenJDK collectors work. So ZGC has taken the copying of these live objects into the concurrent phase. So now we are decoupling, and we're kind of being able to reduce the pauses. So the trend is going towards what the community is asking. So we're moving towards more throughput orientation, as well as achieving that predictable sub-millisecond pauses. One thing with generational is that we are now being able to follow the object churn that I was talking about. So the short-lived and the long-lived, and I also have this concept of medium-lived, which I call transient. We're moving in that towards that direction where throughput is not, as I think Paul mentioned it briefly, and we can discuss that more. But throughput is always a concern when you're talking about multiple threads and concurrent activities happening. And then when we are trying to get the applications to help out with the garbage collection activity. But with generational, we are trying to solve that problem as well of being able to deliver good throughput.
Wow, that was a lot of information, and I would have loved to kind of dive and talk about each of these garbage collectors, but unfortunately we can't. And I love that phrase, "stopping the world." I think we should have that power of stopping the world, not just the
Absolutely.
not just the garbage collectors. So Paul, I wanted to ask you, how does Netflix uses the ZGC? Because I think we read a blog post on how it uses ZGC and the benefits it is delivering at Netflix. If you could talk about the advantages or maybe some do's and don'ts, because I'm specifically asking for the don'ts, because a lot of time what happens is when developers listen to, okay, this company is using this particular ZGC, they might kind of jump onto the bandwagon before without considering a lot of don'ts, like is that the right garbage collector for them? So yes.
Yeah, so very surprisingly, the new generational ZGC garbage collector turned out to be a really good default for our services. And of course, we have many different workloads, right? So, but most of our workloads are just server apps. So they're like a GraphQL server or a gRPC server, and they have to handle like incoming requests. That's kind of the common workload that we have. Now, what we expected with a new garbage collector is that it would actually not be a good option for such workloads, because in theory, you're trading off higher CPU load for lower pause times, right? But most of our server applications are actually CPU bound. So the kind of the scaling limit for these services is just how much CPU can we drive. More requests means more CPU, and we can only run a certain CPU number, like 80%, for example, and then we need to scale to a new instance. So when we looked at it like on paper and kind of understanding what a garbage collector does, the trade-off of, okay, you're going to have higher CPU load, but then lower pause times, it didn't look like a good option. Now, then we just started starting to try it out in practice, and it turned out this assumption was actually not true. What we saw is that because we have lower pause times, we actually reduce CPU usage. So we can drive more requests on the same instance, and we see less CPU usage. Now that seems really counterintuitive, right? Because that's the opposite of what the garbage collect describes of the trade-offs you're making. Now, that is because there's a bunch of side effects that are happening. What happens if you have a stop the world garbage collect, like what Monica was just talking about, and that's something you have with G1. What happens in such a case is that your system very temporarily slows down and it can't handle any work at that moment. What happens in our cases is that because we have really aggressive timeouts on the client side of these services, let's say you have a gRPC client that calls a gRPC service. If that gRPC service slows down for just a very small period of time, the gRPC client decides, oh, this service is not responding, I'm going to time out. And these timeouts are super, super small because the throughput is so important for us, right? So that you don't sit and wait until something starts streaming, for example. So we have really aggressive timeouts. Now, what happens if the service slows down just a little bit? These timeouts start to trigger, and now we get retries. So now suddenly we get more requests to the instance or to the cluster in general, just because the server was slightly slower. And we're talking about milliseconds, right? Typically. But just because it was slightly slower, now we get more requests because we get into a fallback mode. And that means now we have to process all these extra requests that actually would just be fine if we would just let it go through. And now we're driving up the CPU usage. So technically, yes, we are actually handling more requests, but these are the same requests that we were already handling anyway. Now, because of that side effect, if we don't have stop the world pause times, which we don't have with a low latency garbage collector like ZGC, the load becomes more predictable, and we don't have these peaks because of garbage collecting. And we can actually run our service a little bit more hot, so using a higher CPU percentage because it's very stable. We don't get into this unpredictable garbage collection mode, so we don't get into this weird fallback mode. And the end result is that we have a higher throughput on our services with lower CPU. And that is just because all the side effects that happen if garbage collection works. Now, that means in practice that this is a really good default for almost all our workloads. And we have decided this is the new default for all our services. So we were already moving towards JDK 21 and now 22, very soon 23. And we have flipped the default. It used to be G1. Now the default is generational ZGC. And that works out really well so far. The only place where we don't use ZGC right now is on batch workloads, where the type of work is very different, right? You start and you stop at some point, and then the work is done, and you just want to make that happen as quickly as possible. And that is kind of a very different workload where these same constraints don't apply. But for everything else, ZGC is the way to go.
That makes a lot of sense. So, using the constraints that you have for an application, that's how you decide which garbage collector and what precise settings developers or the leads would need. And that brings another interesting question for you, Monica, because as Paul said, there are some settings which are required. And so I know that you have been working with GCs for quite a long time. So, what are some of the obvious ways that you have seen related to the GC settings that are used or maybe not used on projects that could mess them up instead of playing to their strengths?
Yeah, that's a good question. One of the things that when we were evaluating ZGC for generational as well as the non-generational part of it, uh, I was working with LinkedIn, and they have this service called Follow Feed Storage. So we had, I saw a lot of challenges at first because of the heap size, like a huge heap size demand that they had, and the garbage collection needs. The service basically needed to handle high object promotion rates due to the constant eviction of cache entries. So previously they had CMS, and then they moved to G1, and now we were trying ZGC and then generational ZGC. So what we found with the non-generational ZGC was that we still we still had to scan a large portion of the heap unnecessarily. Because remember, I was talking about this whole caching and the promotion rates that we need keep a track of. So when we're doing that, and when we are working with non-generational, this is what one of the things that I highlighted before. So even though it's concurrent and regionalized, and it kind of mitigates some of the inefficiencies that we saw with CMS, in the Stop the World stuff, because eventually you would have a full GC in CMS. We realized that we need to optimize the memory as well as memory configuration, like the heap sizes, and kind of reduce the workload on ZGC in the non-generational case. So we had to cater our workload to adapt to the non-generational ZGC, just because we were seeing the benefits that Paul mentioned with respect to the pause times and the utilization, but it would only happen if we kind of tuned our workload. So it's kind of like, it's not just plug and play, is what I was saying. So then we switched to generational, and it kind of worked really well. One of the things that I really encourage users out there to think about, and to kind of change in the way they think about the maximum heap size. So there is this concept of soft max heap size that's introduced by ZGC, and that is a brilliant concept to avoid growing your heap to the max. Because remember, once you go to the max, that's the top limit of your heap. But if you if your application doesn't need to, then it can stay in the realms of soft max heap size. So what it takes care of is those kind of unpredictable spikes that happen during peak load, because all these basically are serving some kind of storage or some kind of caching. And when you have concurrent accesses, then you do have these kind of peak moments. So sudden memory spikes can be controlled by this soft max heap size. There's this whole concept of sometimes we over configure different thresholds and different stuff, which people have kind of carried forward since CMS, because we had to do that for CMS, just the way the CMS garbage collector used to work. So that kind of thing, we have to think about that ZGC is already very, starting from G1, actually, we have entered the adaptive realm of garbage collectors. And now ZGC is getting even more adaptive. And also in the future, you will see that your memory sizes, these kind of setting max heap size, will be not necessary. So let your first experiment with these newer garbage collectors be, out of box, and because OpenJDK is optimizing for out of box experience. The other thing with ZGC you have to think about, because you're talking about larger heaps, think about utilizing large pages. And if you are on Linux, then transparent huge pages. Those are the things that can help with ZGC, just the nature of the collector and how it kind of works with the operating system. So there's advantage to using and trying these to work in your favor. I think uh, shifting of concept from Stop the World to this concurrent nature, and being empathetic towards the way concurrency in garbage collector works, it's a paradigm shift. But also there's so much advantage, as Paul mentioned already, into how we saw that it not the lower latency actually helped in bringing down the CPU utilization. So maybe counterintuitive, because you're thinking, oh, we're working in the concurrent space. But remember that at depending on how many, depending on the scale of your system, if you are scaling up, you have a lot of cores, processing power, that you can actually work with. So things that they may be gotchas, but I just want to make sure that you understand these gotchas are kind of where we're, as a garbage collector developer, where we are trying to help you. So let us help you in these things. And I think the other thing would be incremental, having an incremental collector is something that we can take advantage of. So if you do want to tune, then know that we don't have to worry about thinking of the entire heap as a contiguous block, we can actually, the garbage collector is smart enough to only collect as much as is needed and get out of the way. So one of the jobs of garbage collector is to get out of the way, and ZGC does that really well. So it's just simple things that we may want to just not relearn, but acknowledge when we go and try this new garbage collector.
I really liked when you mentioned that people who are starting, they should kind of start simple and use things out of the box. And because I was reading, and you also mentioned a lot of people do not understand the different settings that have to be used with the garbage collectors. And when I was reading up this step, there was a similar concern by the authors of ZGC, and they mentioned that a lot of settings that they are making it implicit so that the developers, they don't have to be bothered about something like concurrent GC threads or tenuring threshold and a lot of other things. So they said the minimum configuration that you need is probably just to mention the heap size, as you mentioned, the maximum heap size, so that you have a considerable headroom. So that is beautiful, helping everyone to kind of make use of the best, to get best out of the ZGC. So, Paul, you also mentioned that you were using generational and non-generational mode for different kind of uh, applications that you have at Netflix. So, my question is, how long does the team usually take to determine the right settings for getting the best results from GC like the ZGC? And I think you've already answered this, but if you want to revisit, like, what are the gaps between what the specs of a GC might promise and what they deliver?
Yeah, I think this actually builds nicely on what Monica was just explaining. So if I look at the past, like let's say 10 years ago, and this is also true, there's true outside of Netflix, but also for Netflix services. If you would have to bring a new service to production, we would spend many, many, many days tuning the garbage collector. Like that was an actual job. It's like someone's job was to tune the garbage collector, and it would take so much time. And it was a lot of just you have to understand what you're doing, of course, but then it was just a lot of experimentation. Okay, I changed this thing a little bit. Oh, now this other thing also needs to change, and it was just very complicated. And then you think you got it right, and then you move to a new instance type on AWS, and you can start all over again, because now you have a different CPU, you have different memory, and all your settings are now garbage. So you have to start over again. In recent years, and this is already true with G1, it is better and better to just not touch anything. Just let us figure it out. And this is exceptionally true with the new generational ZGC. We actually don't set any settings. We just turn it on, we enable it, and well, now with the new JEP, we don't even have to say that we want it generational, because we always want it generational, and it will just do its job, and we don't have to do anything. So that whole space of like fine tuning the JVM is kind of just not a thing anymore. It's smart enough to just figure it out, and you should kind of just get out of the way and let it figure it out. There's a few things you can still you have to double check. Like Monica mentioned, the huge pages, for example, that is something that needs to be enabled on your operating system, and sometimes it's not enabled by default. So you have to like double check these things depending on where you're running your software. That like in the kernel, such things are enabled, because otherwise, if the operating system doesn't have it or it's not enabled, the garbage collector obviously can't use it. So these are kind of things to check, but that's actually really outside of the space of the garbage collector directly. So yeah, just turn it on and see what happens.
It's really interesting to understand that all the pain that you mentioned about fine tuning the garbage collector is not so much with the new garbage collector. That is really interesting to learn. And you, as you mentioned, you're already using the generational mode. So, Monica, this question is for you, because this step also talks about deprecating the non-generational mode. And since you have been working in the garbage collector space for a very long time, and you also lead the JVM team at Microsoft, So, what's your opinion and experience of deprecating of options with GCs? How much of a pain is that, and what are the risks that are related for any
I th-
deprecation?
that's a great question. There's different aspects to it, because we not only, I'm thinking about from the JVM perspective, but also, so there's this whole maintenance perspective as a JVM developer, but also as an OpenJDK build provider. There's something that we have to explain to our the partners that we serve, right? So I think, in this particular case, as Paul mentioned, it's something that we need to understand ourselves, that it's going to help us. As I said, even G1 started as single generation, but that's just how garbage collectors evolve. You start with what the garbage collector is supposed to do, how it's going to function, and then you'd go to the hypothesis of when most objects die young. So that's just the hard fact, right? So that's where we're going to go to. So I think transitioning to generational mode as an end user, I think it's going to be quite seamless. Most applications should see a benefit. So because we are trying to this kind of generational, bringing in the generational nature to a garbage collector is something that helps memory management, right? So we are trying to not only have age the objects appropriately, but we're not triggering garbage collector every time that we see a particular threshold exceed, because now we have different thresholds for young and old. So that's one of the things. So again, most applications should see lower CPU overhead, as well as Paul already mentioned. So those are the simpler things. Um, for as an ease to switch, right? As an OpenJDK build provider, like it's the same switch, right? We just use ZGC, and now you get either you get the generational one. So it's more of an education, as far as I'm concerned, like trying to explain to these are the things, this is enabled now. Will there be a configuration adjustment? I think, going back to what I said, if you're already coming in from a ZGC to a generational ZGC, then you're probably already using large pages. You're already using the softmax heap size. So that would be, please try those things. Please bring them forward to, so there should not be major adjustments. But coming in from a different collector, you will see a difference. But that's expected of migrating to a new collector anyway. So that is should not be much different than what you've already been doing. We moved from parallel GC to G1 already, so we have learned some things. I think this will be much easier because it's kind of dealing in the G1 realm already, but giving you more predictable pause times. Let's go to applications that have a unique allocation pattern, right? So non-common type of applications. So applications that don't follow the typical generational hypothesis, right? So generational mode may not be for those applications. And so we won't be able to predict the performance for them because because they may have had, may need to change the way the application works in a little bit. The workload maybe need to be reworked to fit the generational hypothesis. Again, if you're coming from G1, then G1 was also generational. So I'm sure you had to make some adjustments for that. So you will have to maybe make adjustments for that for here as well. And that's usually what I was talking about. You have the medium lived. So medium lived, like the transient. So you're dealing with transient. So you may have to tune the lifetime and maybe adjust threshold. So that now you going into the specialization mode, which you had to do for G1 anyway. What else? Backward compatibility. Again, backward compatibility too from JVM developer, it's easier to deprecate it, and then just have to think about tip and development towards the generational nature. For us, we will support both until OpenJDK decides to, like, until JDK 23. So that would be there. There may be initial friction in switching, and there, we will provide help as much as needed. Any old tuning that people are bringing forward, we may be able to help tune that as well. So there may be some hand holding, but I don't anticipate that to be a major audience for that, because I think it's going to be a positive thing for everybody anyway.
That's great. It's great to see. Yes, there will be challenges, but there's solutions available, right?
From my perspective as just a user, I always want generational. I never want non-generational. So I think the only reason that we currently have that flag so that we can go back to non-generational is really just so that we can compare the before and after in an easy way. That is interesting just to see like the difference. But other than that, I think everyone should always have generational enabled, and that is also why the non-generational is not deprecated, and it will be removed probably soon.
Yeah. So, Monica and Paul, I don't have any more questions for you. So, if you have any closing comments before we move to our fun sections.
Okay. Well, I think as a performance engineer, I think this is the right step forward. I feel that the generational mode is another feather in the hat of ZGC. It's already trailblazing, and now we're getting the advantage of a generational garbage collector. So it. It's a big direction in the low latency spectrum, and much needed. So I think for developers, your specific workload uh, will be will should benefit if it follows the generational hypothesis that, like I mentioned. And now ZGC is innovating the way adaptability works for your application. So think of it as hopefully as a plug and play, again, out of box. Keep out of box in mind, and then if you have any feedback, use the hotspot dev mailing list, or use hotspot GC use mailing list. This way we can hear you and get your concerns, and hopefully in the next JDK release we'll address your concerns.
Paul, any closing comments from you?
Yeah, maybe I just want to point out how exciting it is right now to be a Java engineer, because there's just so much stuff happening in the last few years, and this stuff is all really impactful. Because just talking about garbage collectors, right? We went from at Netflix, we went from Java 8 to Java 17, and same garbage collector. We were on Java 8 on G1, Java 17 still G1, and we saw 20% better CPU usage. So that the CPU usage basically dropped at 20%. That's a lot of like cost savings for us in cloud costs. And all we needed to do was just upgrade the JDK. We didn't do any tuning or any work. It was just upgrading the JDK, and we got all this stuff for free. Now we move to 21 and 22. We start using generational ZGC, and again, we get a lot of performance just for free. Don't need to do any work. We don't need to do any tuning. We just get better performance. So the JVM is just doing so much for us, and just making everything faster and easier to run, basically. And then, of course, there's all the other stuff in Java, right? This is a Java developer, all the new language features that we're getting in the recent releases, things like virtual threads are super exciting. That's going to change everything about performance in my eyes. So yeah, it's pretty exciting time to be in the Java space.
Absolutely. And as Monica said, don't forget the term out of the box. So use what the JVM is offering you. And as Paul mentioned, just upgrade to the latest version and you'll get so many benefits. So thank you so much, both of you. It was lovely to learn from both of you about the garbage collectors in general and ZGC in particular. I loved it. And now on to our fun sections. So, Monica, I'm going to start with you. So, the first one is tongue twister. So, Monica, you cannot cheat and you have to say it at your usual reading speed. So, now on your screen, you can see one, and your time starts now.
Shifty Java sharks silently shuffle seashells by the shimmering shoreline as sly shadows slip and slither while the sneaky garbage collector sifts through shiny shards of smashed software.
That was great, but you said it at a pace which is slower than your usual one. Just one hit, shifts and shifts. Okay, so I'll give it to you. So, you won. So, Paul, ready? Are you ready?
I guess so. This is much harder than just talking about garbage collectors, honestly.
So,
Sassy
this one's
Seas,
for you. Yeah.
Sassy Sea Spirits. Oh no. Sassy Sea Sprites sip on shellfish soup at the seaside while Java's sharper shadows shift on shimmer and sneaky software scripts slip through the garbage collector's teeth.
Oh my God, that was great. You said you'll okay, but I'll give it to Monica because you tripped when you started with it, right?
Oh.
So Monica wins
This
this
one should
round.
definitely go to Monica. Yeah.
Okay, so the next round that we have is enacting the emojis. So I will show a statement to you on your screen, and you have to react to that statement in the form of an emoji, which you cannot type out. You have to enact that. So here is the first one. Java 23 is about to be released. That was a cute one. So Monica, what was your emoji? It was like the
So it
dancing
was
one
like
or
the popping of the party poppers like
punk?
that.
Ah,
Yeah.
right. That was good. You are doing really good. Now, this is the second one. Performance tuning is a lot of fun.
That's a heart. I don't know if we could go like
Yes,
this.
yes, yes. We could say that. So I can see both of you are kind of in love with performance tuning. So that was great. And this is the last one. So if you found in a parallel universe, so you'll probably be found singing rather than doing your current jobs. So you'll have to explain, both of you, why that reaction.
I think it would be better for any universe if I just don't sing.
Same here. I think people do not want to hear me sing.
Thank you so much, Paul and Monica. It was such a fun conversation with you, and of course, a lot of learning. Thank you so much for your time, and absolutely a pleasure to learn from you. And I'm sure everyone who will be listening to this interview, they would love what you all shared, both of
Oh,
you
thank
shared.
you for having us. Thank you so
Thank you
much. I
very much.
appreciate this.
That
Yeah.
was fun.
Thanks.
The pleasure was all ours. Thank you so much. And until the next JEP episode, bye bye.